So we started with the cloud computing overview, along with the traditional and cloud computing we discussed. We also discussed about the legacy IT, what it happens, what is a data center, what is a corporate data center we discussed. So it is a leased space or else it is a owned space, and the IT equipment is owned by the company itself. And then we have the connectivity that exists between the corporate data center to your corporate office. And there are a lot of expenses that are associated with this traditional IT, where you need to manage all these expenses upfront with respect to the data center building, security, licensing costs, power, and everything we need to really maintain. Okay, but when we try to get into the cloud, the only thing what we have is we need to have only the computer along with the internet connection, so that we'll be able to manage everything. So we discussed something like we used to have something like rapid elasticity. We used to have something like on-demand self-service, the resource pooling, okay, as well as you have these major services, okay. And then there is no need for you to make any payments upfront. There is no need for you to make any payments upfront. What exactly we need is we need pay as you go model. We'll be paying for only the services that we consume at the end of the day or at the end of the month. That is what we generally do in this cloud computing here. Okay, and then we saw the differences between cloud computing and traditional IT, right? So it requires human involvement. It is a self-service. You'll be able to purchase the computer system on your own. Okay, as well as you'll be able to get the broad network access. You'll be able to get this rapid elasticity by your own, and then there won't be any human involvement for the purpose of doing all these particular things. Okay, and here the usage is not typically measured because you own the systems basically. Okay, and we discussed something like when we try to have the things when we have the file server on premise in traditional computing, we have something like Dropbox. You get the subscription, you pay for the storage, and then you use this one. Similarly, when you're having something like the Salesforce in the case of cloud, we are having something like Microsoft Dynamics in the case of CRM on premise. Basically here these are all the things that you need to maintain. And then we discuss the examples of what are all the things that you want to deploy a website and on premise. The total delivery time is going to be something like 3 to 6 months before the things go live in the case of deploying a website on premise. In the case of cloud, everything can happen within a week. Everything happen within a week. From the inception to the production, everything will happen within a week. That is the major difference that you can see in this particular case. Welcome, Reddy. Okay, then there are three types of cloud deployment that we will see. Okay, the first thing is that there are three things that we need to really talk about. The first thing is you have something like infrastructure as a service. You have platform as a service, as well as you have something like software as a service. First, let us understand what exactly a computer will contain. Okay, in case if you are going to have in case if you are going to have a computer system, okay, what basically it contains? Can anybody tell me, like, what basically it contains? What is really required within the computer system? A computer will have the hardware, it has the operating system, it has the software compilers and interpreters. So the software compilers and interpreters are generally treated as runtime environments. It has the applications that we generally do. What are these applications? The Salesforce is a application, CRM is an application, okay. And then we have the data, we have the data in this particular case. So if you know all these things, we are going to have these things here. Basically it is going to have 1 minute. Share. See, suppose if it is your private cloud, that means that a private cloud is nothing but the cloud that you manage on premises. So within this one, what you are having is whenever you are having a computer system or a laptop, what you generally have, you have something called as a server. What the server generally contains? The server contains the motherboard, the CPU, the storage, the memory, the network. These are all things that will contain, which is nothing but your server. You forget about hypervisor right now. Okay, but apart from that one, it need to have the operating system. What is that operating system? It has something like Linux, Windows, Mac, or anything Unix for that particular sort. Okay, those things will be available. Can you hear me, guys? Sravanti, can you hear me?
Yeah, Ravi, we can hear you.
Okay. Okay. So these are all the things that you have here. That means when you are trying to install all these servers within your private cloud on premise within your corporate data center, you are the person, or else your infrastructure team or your admins are the people who are responsible for the purpose of managing everything. That means that everything is going to be managed by you, which is treated as a private cloud. Okay, so I told you, right? A private cloud must include the self-service, multi-tenancy metering, and elasticity on your own. On your own, you need to maintain everything on your own. But when you go to this infrastructure as a service, what is this infrastructure as a service? This infrastructure as a service means it is your public cloud. Public cloud in the sense this is something that is expected to be existing on public cloud like Amazon Web Services. It might be something that is existing on Azure. It might be existing on Google Cloud. Okay, within that one, what happens is uh, the motherboard, the hard disk, the memory, and then the storage, the network, those things will not be maintained by you because those things will be provided by your uh, cloud provider. Those things will be provided by your cloud provider, and what are the things that will be provided by your cloud provider is treated as infrastructure as a service. What that infrastructure contains, again, I'm telling you, the motherboard, okay, the CPU, the storage, the hard disk, the memory, the network, the bandwidth, what are all the things that are being provided by your cloud provider? These things are treated as infrastructure. So that particular infrastructure will be provided by your cloud provider, but apart from that one, the data, the applications, the compilers and the interpreters, and then the operating system has to be managed by you. So that is what is treated as infrastructure as a service. That is what is treated as infrastructure as a service. Guys, is it clear to you? What is the major difference between the previous private cloud and the infrastructure as a service? In the case of the previous private cloud, everything from A to G has to be managed by you. Okay, But in the case of this infrastructure as a service, you are the person who will be responsible only for these things: the operating system, the data, the applications, and the compilers and the interpreters. Okay, this is what is treated as infrastructure as a service. But when you go to the next one, which is treated as platform as a service, in the case of platform as a service, what happens is the applications and the data will be maintained by you only. So that means that you are responsible for only your applications that you are developing, as well as you are responsible only for your data. But what is not being maintained by you here? The operating system and the runtime environment is not going to be maintained by you. Is not going to be maintained by you. So that means that the infrastructure, the operating system, and the runtime environment is not going to be maintained by you. Only you are responsible only for your applications and then the data. That's it. For example, we'll be seeing the examples at a later point of time. But again, when you go to the next one, what is the next one here? The next one is nothing but your SaaS. What is the SaaS? Software as a service. For example, when you try to take the Gmail, Sravanti or Cherishma, when you have a Gmail, what is in your control? You tell me. In the case of a Gmail, only your user ID and password are in your control. Using that user ID and password, you need to create the account and then you need to log in. But you are not the owner of Gmail. You really don't know what is the application that has been used to develop that Gmail. You really don't know what servers are being used to run that particular Gmail. Okay, all these things are not totally related to you. Only you will be able to use only that application. That is what is stated as SaaS. What is that SaaS? That is nothing but your software as a service. That is nothing but your software as a service. Okay, so that is what is treated as SaaS here. So anybody differentiate between what is the difference between SaaS and what is the difference between SaaS and PaaS and IaaS? In the case of IaaS, infrastructure as a service, you will be responsible for the. Again, I'm going back to the previous slides. In this one, you are responsible for everything except the infrastructure. But in the previous slide, you will also be responsible for this one also. The bottom layer, what you're talking about, is nothing but your infrastructure. The bottom layer, what you're talking about, is nothing but your infrastructure here. Okay. Now, but when you go to the infrastructure side, you will not be maintaining the infrastructure. Infrastructure will be supplied to you, but you are responsible for everything else. You are responsible for everything else in this case. Okay. Similarly, when you go to this platform as a service, you won't be responsible for the operating system and the runtime environment, but you will be responsible for your data and applications in this case. Similarly, in the case of the cloud computing SaaS, software as a service, you are not responsible for anything for that matter. You are supposed to consume the application. Okay, that is what is SaaS. And our Snowflake is nothing but SaaS. It is a software as a service existing within cloud environment. That means that this is something that can exist only within the cloud, having software as a service feature. Okay, there is no need for you to maintain the infrastructure. There is no need for you to maintain the applications. The application is already built for you. You need to understand how to use that particular application. Okay, that is what is SaaS and Snowflake. Rudrapa, is it clear to you what is the purpose of this? What is the purpose of this software as a service and Snowflake? Are any questions? Jones, is it clear? Karishma, Munna Chaudhary, is it clear to you what are all these things that we are talking here? What is Snowflake and what are the different types of services what we have? Is it clear to you? Then once this this is clear, let us go to the next concept. You can see the differences here. You have this private cloud, you have this infrastructure as a service, you have this platform as a service, as well as you have this software as a service. In the case of this private cloud, everything has to be managed by you. You are going to have the greater responsibility and greater control. Okay, but in the case of this infrastructure as a service, this thing is not there, but everything has to be managed by you. But in the case of PaaS, platform as a service, you are going to maintain both the data and the applications, but everything else is given by the cloud provider. Okay. But in the case of SaaS, you need to simply consume the service. You're going to have the little responsibility and little control in the case of this one. So these are all the different types of cloud service models what you're having here, and Snowflake is something that comes under the category of this SaaS, software as a service, existing on the public cloud. Okay. Now I told you, right? In the case of the private cloud, you are the person who are going to build and manage the cloud deployment in-house, basically in your data center. Okay. So everything you are supposed to purchase, manage, and control everything. Security is something that you will be responsible in this one. But when you go to the public cloud, as I have told you, nothing you need to manage. Nothing you need to manage. The only thing that you are expected to have is you're expected to have the internet connection, a laptop, or the servers on your corporate office, and then you'll be able to access this public cloud. So, who are all the major cloud providers that you are having here? The major cloud providers happens to be Amazon Web Services, Azure, and the third one is Google Cloud Provider. Google Cloud Provider, and this Snowflake is something that will be running on any of these clouds. It can connect to Azure, it can connect to AWS, as well as it can also connect to uh, Google Cloud also as well. That is what is treated as Snowflake. Okay. Then once this public cloud is completed, let us try to understand what is this hybrid cloud. We'll try to understand what is this hybrid cloud. Okay, I'll increase my voice. 1 minute. Can you hear me, Munna Chaudhary, now? One minute. అమ్మాయి కొంచెం సౌండ్ తగ్గించిందమ్మా. Yeah. So when you see this hybrid cloud, what happens is you have your applications that can exist within the public cloud, as well as you can have your applications that can exist in your data center also as well. For example, let me tell you, I have a company which is running the business. I have the company which is running the business of a uh, retail store. Okay, so till today I have not got into the cloud computing system. Now everything is running on on-premise only. Now everything is running on on-premise only. Okay, so when everything is running on on-premise, what happens is the salesperson of cloud of AWS has come to my organization, and then he told the various benefits of using a cloud. Then what I did is I got interested within the cloud, and then I want to move all my infrastructure into the cloud. I want to move all my infrastructure into the cloud. So when I want to move my complete infrastructure into the cloud, I cannot all at once do a sudden transition, right? I cannot all at once do a sudden transition into the cloud, because transitioning from your on-premise to cloud, it will take a lot of effort, money, and other resources also as well. But here, because for example, I'll telling you, you are working in Hyderabad, okay, and you want to shift to Bangalore and then purchase a house. Okay, now you can't directly be in Hyderabad, purchase a house in Bangalore, and then you cannot shift, right? The one thing is that what is the better thing that you do? The better thing that you can do is you can have the option of you can have the option of going to Bangalore, take a rented apartment, stay there for some time, understand the locality, and then you purchase a house. So the transition is going to take some time. That's the reason when you need to change your infrastructure from on-premise to cloud, the transition cannot happen all of a sudden. The transition cannot happen all of a sudden. What you are expected to do is that you are supposed to do it in a phased approach. So in such a case, what happens is when you are doing this phased transition, what happens is some of your applications will happen in your data center, and some of the applications will be migrated to the cloud. In such a case, what happens is that your applications will exist in both the two clouds. That's the reason what we do is that we call such type of setup as hybrid cloud. We call such type of setup as hybrid cloud. Okay, so that's why how many types of clouds what we have? You have public cloud, you have private cloud, and then you have this hybrid cloud. Okay, as well as how many types of cloud service models what we are having? We are having three types of cloud service models. One is infrastructure as a cloud. The next one is platform as a service, and the third one is software as a service model. So these are the three types of cloud models, and then the cloud deployments will exist in three things: public cloud, private cloud, and third one is hybrid cloud. Are you guys clear with these things? Or any questions you are having here? Please let me know before I jump on to the next topic. Guys, I would appreciate if you can type your responses in the text window, or else if you can unmute yourself and then let me know. That also it's good. But at least requesting you to be responding in one of the manners. Okay. Thank you so much. Cool. No. This multi-cloud is something that we don't discuss here, but I just want to limit the scope of Snowflake. The Snowflake is existing within this public cloud. Either it can exist in Azure, or it can exist in AWS, or else it can exist in Google Cloud. Okay, but it's something that don't exist within on-premise. It won't exist in the private cloud, and there is no concept of hybrid cloud in the case of Snowflake. Okay, that is one thing that I want you to understand. See, when we are going through these cloud concepts, or when you are going through this data warehousing concepts, I kindly request you to understand one thing. Please try to apply these concepts for the Snowflake, because ultimately we'll be tending towards into the universe of Snowflake to understand the Snowflake concepts. Okay, that is one thing that I want to make you to understand. Okay. Again, private cloud, I have told you these are the things that are being managed by you, everything. But in the case of the infrastructure, platform as a service and software as a service, I just told you this is as a revision. Public cloud is done, private cloud is done, and then hybrid cloud is done. And as I told you, cloud computing is something on-demand delivery of IT resources. Can anyone tell me what are these IT resources that we are talking about here? What are these IT resources? Those IT resources are nothing but your compute, storage, memory, network. Again, I'm telling you, compute, storage, memory, and network and databases. These are treated as resources. Okay, these are treated as services. So when you want these services, there is no need for you to book these things in advance, because you can have the option of acquiring them on demand, and then there is no need for you to pay for upfront for all these things, pay in advance. But what you do is that you need to pay for the extent what you use. That is what is called as pay as you go model. So it is treated as a metered service. Why it is treated as a metered service? Because you pay for only the things that you consume. That is what is treated as an metered service, which is similar to the type of current bill or the electricity bill that you get every month. Okay, then cloud computing, as I have told you, like water and electricity uses, you pay for what you use. You can choose the services you need, and then no need of these long-term contracts. Anytime, any duration, you can have the option of disconnecting your services also as well. Disconnecting your services also as well. So these are the things that we generally talk about in this particular case. We talked about infrastructure as a service. We talked about platform as a service and then software as a service. And the software as a service is nothing but your Snowflake that we really discussed. Okay, so other things are not really required, but these are all the cloud computing concepts that we discussed. Okay, now you know these buzzwords what we talked about, right? In the earlier slides. 1 minute, I'll show you. What are the buzzwords that we talked about? We talked about infrastructure, we talked about compute, we talked about storage, we talked about networking. Okay, public cloud, private cloud, hybrid cloud. These are all the things what we discussed. So finally, what we conclude is Snowflake is a public cloud that exists on Amazon Web Services, Google Cloud, or Azure, which has the capabilities of software as a service. It doesn't exist on on-premise. It doesn't exist on private clouds. So this is the first concept that we thought of for discussing. With this, the cloud computing concepts is completed. If you have any questions, I have 5 minutes of time. You can ask me before I go on to the database or the data warehousing concepts. Sravanti, is everything clear to you? Larry Jones, Una Chaudhary, Karishma, are you comfortable? Okay. Now, let us start the day two concepts. Okay, that is nothing but your data warehouse and OLAP concepts. As I have told you, Snowflake is nothing but a public cloud with software as a service having these data warehousing features. It is basically a data warehouse. Okay, so before understanding what exactly is a data warehouse and before understanding what we need to really do with this data warehouse, we need to understand these concepts here. Okay, so without wasting much of the time, let us go ahead and then start this data warehousing concepts here. So today, what we are going to do is that we'll be discussing about what data warehousing is not, because there are two things. If you want to understand the concept, if I need to tell you what is a database, I'll tell you what is not a database first, and then we'll talk about what is a data warehouse and why should we use one data warehouse. Okay, we will discuss the differences between a data warehouse and data marts, as well as we'll discuss about the ELT versus ETL and the modern data warehouses also as well. Okay, see here, one thing is we are not really going to do a deep dive into the data warehousing concepts, the general data warehousing concepts, but what is really required in order to make sure that you understand the concepts when we go into the data warehousing platform, all particular concepts are going to be discussed in detail. All those data warehousing concepts are going to be discussed in detail. Okay, so let us start here. These are all the words that you need to be clear about in this data warehousing architecture. The first thing is we need to understand what is online transaction processing, online analytical processing, what is a data warehouse, what is a database, what is this ETL, and there is something called as what is ELT, that is extract, load, and transform. And what is the difference between SMP versus MPP? Anybody knows what is SMP and MPP in this group? You can please type it in the chat window. What is SMP and MPP? What is SMP and MPP? SMP stands for symmetric multiprocessing. Okay, as well as MPP stands for massive parallel processing. One is symmetric multiprocessing and the second one is massive parallel processing. These are the two things that we need to talk about, and then we need to understand what is a shared nothing architecture and what is shared everything architecture. We need to understand these data lakes, the star schema concepts, dimensions, facts, and master data and transaction data. Okay, these are the things that you need to be clear with the data warehouse. Okay, in order to make yourself comfortable within the Snowflake journey. In order to make yourself comfortable within the Snowflake journey, these are the things that you need to understand. So here, first thing is let us talk about this one: OLTP versus OLAP. Can anybody open your mic and then tell me what is happening here in this small diagram? What is happening here? You have an ATM. In the ATM, what we generally do, we try to deposit the cash, we try to withdraw the cash, or else we try to transfer the funds between the two accounts, basically, right? Withdrawing the cash, depositing the cash. Yeah, yes, Karishma, thank you. We try to withdraw the cash, we try to deposit the cash, or else we try to manage these transactions. Okay, so all these transactions are going to be recorded within a system, and that system is treated as a OLTP, that is online transaction processing system. Okay, So online transaction processing system is nothing but a database that can be used for the purpose of recording your business transactions. It is a database. Oracle is a OLTP system. SQL Server is a OLTP system. MySQL is a OLTP system. Okay. Now, once you do those transactions, okay. So assuming that you are doing the transactions for the entire month. Okay. Now, at the end of every month, what would you like to do? At the end of every month, you would like to understand the summary of your transactions. What is the summary of the transactions? The summary of the transactions is basically treated as reports. The summary of the transactions are basically treated as reports. So what are the reports? I want to know how much is the amount that I have spent, how much is the amount that has been withdrawn, or how much is the amount that I have saved. All these particular things I want to get. So those things are treated as reports. Okay. So when we are trying to use the information for the purpose of reporting and analysis, that type of database is treated as OLAP, that is online analytical processing system. Okay, and it is treated as a business intelligence solution. So from this type of database, we utilize this database only for the purpose of creating these dashboards and reports. So this is what is stated as OLTP and OLAP. Is that clear to you? Now the thing is, there are two things. Without having this OLTP, can you have this OLAP? Guys, can you please respond to this question? Without having the business operations, can you expect the reports and analysis? No. Okay. Because when you want to have this OLAP system that should exist, what you need to have is you need to have the transactions that should happen in this database. That's why the survival and existence of the information present in OLAP is totally dependent on the information present in these transactions. That is the reason what we can say here is this OLAP. What you're having here is a data warehouse. It is treated as a business intelligence solution. That means that data warehouse is nothing but a OLAP solution, okay, that exists in the form of a database that contains the information that can be used for the purpose of reporting and analysis. That's what is OLAP here. And Snowflake, when we talk about Snowflake, is treated as a data warehouse, which is a OLAP solution that exists in the cloud and that offers as a software as a service feature, and that offers something called as software as a service feature in this particular case. This is what is OLAP here. Now when you go to the next slide, it says something like this: a data warehouse is not a copy of the source data. Why it is not a copy of the source data? Because there is a difference between the transactions and the report, right? Can anybody tell me, will the report contains detailed data or summary data? What type of data that report contains? Does it contain detailed data or summary data? Let me stop. What type of data? Yeah, the reports contains the summary data, right? So here also, what happens is we are not simply going to dump the data from this OLTP system into OLAP. Okay. Instead, what we are going to do is we are going to do some transformation that will help me to transfer the data from the detailed form to the summary form. That's why OLAP is not a copy of the data within the OLTP. Okay. For example, if we have the daily sales here, we'll keep the monthly sales here. If we have the daily sales here, we can summarize the data into weekly sales, and then we can keep it here. So that's why what happens is OLAP contains the summary data. That's the reason when you go to the next slide, what happens is see here, a data warehouse is not a copy of the source database, as well as it is not a dumping ground. It is not a dumping ground because we do some conversion. That conversion is treated as transformation. That's why in the case of ETL, T stands for transformation. T stands for transformation. And again, when you go back here, what we are doing here, for the purpose of transforming the data here, first thing is what we need to do with the data first. We need to pull the data, right? Karishma, don't you think that we need to pull the data? Or without pulling the data, can we transform the data? Karishma or Munna Chaudhary, without pulling the data, we will not be able to convert the data, right? Converting the data is treated as transforming the data. Pulling the data is treated as extracting the data. Okay, first thing is for the purpose of bringing the data into OLAP database, the first thing is you need to, yeah, thank you, Rudrapa. So for the purpose of for the purpose of loading the data into OLAP database, the first thing what we need to do is we need to pull the data. Pulling the data is treated as extracting the data. Then we can transform the data. Okay, after transforming the data, then only we'll be able to load the data. Okay, so extraction, transformation, and loading the data from the OLTP systems into the OLAP system is treated as ETL. That is nothing but your extract, transform, and load. That is what is treated as extract, transform, and load. That is what we do with this data warehouse. So here, the slide, when we go here, we'll be able to see here one thing. Let me do one thing here. Yeah, these are all the different OLTP databases that you are having in the company. Okay, and what I need to have is that I want to have a data warehouse here. When I want to have a data warehouse, the first thing what I need to do is that I need to pull the data. Pulling the data is treated as extraction. Once I extract that particular data, then what I need to do is that I need to stage the data. See here, staging the data is treated as a temporary layer. For example, you are in Hyderabad, okay, and you want to go to Delhi, assuming that. Assuming that there is no direct flight that is available to Delhi. Okay, then what you need to do is that you need to take a connecting flight. From Hyderabad, you need to go to Calcutta or so, and from there, you need to go to Delhi. What is that Calcutta? Is that Calcutta as a temporary landing or permanent landing? Calcutta. Is Calcutta a temporary landing or it is a temporary landing? Okay, so that's why till we reach the final destination, we should have some place. Thank you, Samanthi. Till we reach the final destination, we should have some place where we can have the option of keeping the data for some time. Okay, so while we are trying to extract the data from these OLTP systems, what we are not doing is we are not only we are not only bringing the data in small terms. We are trying to bring the data in gigabytes or petabytes of data or terabytes of data. Okay, suppose if the OLTP system is going to contain the detailed data, like for example, Suppose when you go to a public store like Walmart or else IKEA or else something like more something of the sort, what happens is in a day, assuming that there are some 3,000 customers that are coming, okay, and 3,000 customers are purchasing something like 30 items per customer. Okay, in a month, how many transactions are going to be there? That is going to be something like 3,000 customers into 30 items into 30 days. Those many transactions will be there. Okay, now in the data warehouse, I can't keep all the detailed data. What I need is I need the summary. That means that I need the summary for a month. What I need to do, I need to know the total sales day wise. So obviously, what I need to do, I need to bring all the data, keep it in a temporary place or a database for some time, do all the calculations what are really required, and then finally load the data into this data warehouse. Finally, load the data into this data warehouse. So the process of bringing the data from the OLTP sources into the database is stated as ETL process. That is what is stated as extract, transform, and load process. Is that clear to everybody, or any questions you are having? Please let me know, because this is very important. As the data engineers of the Snowflake, the first thing that we are supposed to do is we are supposed to implement this ETL process for the purpose of bringing the data into the Snowflake, because Snowflake is a data warehouse that is implemented in the public cloud using software as a service. Okay, so if you understand ETL, mm, if you understand ETL, you'll be able to understand this data warehousing process. Okay, I'll stop here for today. Please let me know if you have any questions. I'll answer them, and we'll get into the next class. Please let me know. Sravanti, is it clear to you? You can open your mic and then talk, Sravanti, or Mona Chaudhary, or anybody for that matter.
Yes, Ravi, it is clear.
Yes, sir. Clear, sir.
Okay, thank you.
Yeah, it's clear, sir.
Who is the who is the participants? Mona Chaudhary. Reddy is there.
Yeah, Ravi, it's clear.
Venkatappa is clear.
Yeah.
I don't see the name of the person, that is something like waiting for CRTC 13. May I know the name of the person? Okay, that's okay. Okay,
Uh,
so we have
Ravi
understood.
Pani couldn't join today actually. He's stuck somewhere, so he told he'll listen to the recording and he'll be joining tomorrow.
Okay, no problem, madam. No problem. Thank you. Thank you. Thanks for the information. So, we discussed about cloud computing. We discussed about the types of cloud computing models, IaaS, PaaS, and SaaS. We discussed about public, private, and hybrid clouds. We discussed about what is a data warehouse, what is OLTP, and what is OLAP. And we just started with ETL, that is a extract, transform, and load process. Okay, we'll continue tomorrow with all these particular things. Okay, and tomorrow we'll be completing this cloud and data warehouse concepts. Make sure that you are comfortable, and in case if time permits, we'll start off with the Snowflake introduction. We'll start off with the Snowflake introduction. If tomorrow, if it is going to take the whole class for completing this data warehousing and cloud fundamentals, maybe today is Thursday for you, right? Okay, Friday we'll be starting the Snowflake first class. Okay, I'll do that one, Larry Jones. I'll do that one. Thank you. I'll share today's and yesterday's slides also as well.